Right. Hello. Thank you very much, Jerry Presley, Oregon State, associate professor here in wood science. And today I'm going to give you an update on a project that we got last year looking at developing some methods for mass timber building inspection. So as everyone knows, number of mass timber structures are rapidly growing across the United States. I'm sure everyone's seen Woodworks graphic on their website with all the new projects going on. And as these age, we're going to get a mixed population of things that have problems, things that don't have problems, um, ultimately stemming from issues around design and then just buildings getting older, right? So I've got a couple of pictures from a European publication 5 years ago at this point, where they went through and identified some problem areas. On the left, you have examples of poor design, exposed mass timber elements that are subjected to moisture exposure and fungal decay, and some issues around plumbing. Buildings are all going to have plumbing, so some things are bound to go wrong at some point. So these panels are going to get wet at some point in their life cycle. But how do we get around this? How do we diagnose these issues? And ideally, if and when these happen, we want to be able to get a handle on how big the problem is, where it's occurring, and of course, once that's done, it needs to be stopped, right? Before it becomes too big of an issue. And so our approach, we proposed to look at resistance drilling for potential use in mass timber inspection. Essentially, what this method is it's a drill with a very fine needle instead of a drill bit. And that bores into wood, and the equipment will measure the resistance to feed, forward motion, and resistance to drilling. So this is an example of some output of one of these resistance drills. This is the IML Resi. Essentially, one of the applications they use this a lot in, one is standing trees, but for wood commodities, they're using it for utility poles. Go into the pole and you get this regular pattern of early wood, late wood, early wood, late wood. And then if you have a void, you see a drop in resistance that is indicative of fungal decay or well, most of the time it's fungal decay in a pole. So we wanted to look at whether or not we can use this effectively to inspect mass timber elements. So moisture issues in mass timber buildings may cause issues like delamination, fungal decay, and both of those are have a very negative impact on structural performance of the composites. And so what we are doing now is starting with MPP blocks. We are we've got these 8x8-inch blocks. We're intentionally delaminating, exposing these to fungal decay at essentially generating different decay stages. And what we want to do is determine whether or not we can use this resistance drilling technique to detect delamination, and we know we can use it to detect decay, but our questions are, how early in decay can we detect it? Can we use this equipment to detect? And we also need to sort a few things out with mass timber. So for example, it's round piece of round wood utility pole. It's got a regular repeating pattern of early wood, late wood. That's a different story in a composite, right? So we need to get a better understanding of what a resistance drill profile looks like in these different mass timber composites. So what we're doing, student working on this project, is taking two different tools, the IML Resi and the Rintec resistograph, and taking these 8x8-inch test samples. We're starting with NPP because that's what we had available at the time, and essentially drilling a grid where you have both pieces of equipment that drill in a grid pattern across these specimens. We're doing this with controls, delaminated samples, and then our variably decayed samples. And so the idea is, particularly with the decayed samples, you're going to have points of fungal entry. And so you're going to have more decayed wood over here. And as the fungus advances into the middle, it becomes, it's less decayed because the hyphae have been in contact with that wood for a shorter amount of time. And so ideally what we'll be able to do is identify what kind of resolution we have with this equipment to identify decay. Some initial results here on the delaminated samples. These are the drills we have so far. These are a couple of, this is an example of probably our best bet or most obvious signal that we're getting from delamination. So you kind of have what looks to be a semi-regular pattern of the needle going through MPP, the different lamellae, and we have one delamination, one example of delamination in this piece, and you can see the drop in resistance for both. Now there are some other drops in resistance that are natural parts of the composite. And so part of this project is seeing if we can train a model to identify what is and is not delamination compared to other drops in resistance that are normal parts of the panel. So we're just getting some of this data now, so we don't have a whole lot. We also have this is the exciting part. The rotten samples are some of them are going now or just about to get it going. So we are rotting these MPP blocks in these plastic totes. We essentially get these wet and then we sterilize them in our kiln and then put a bunch of fungal spawn all over them and let them rot. So the idea is to pull them out in 2-month increments, and you'll get different levels of decay to measure. So with that, I'd like to thank our team, Opiemi Ojule, the master's student on the project, the other OSU faculty involved, and of course TDI for the cash. So thanks a lot.